In this video, I'll be teaching projectile motion. You understand projectile motion from first principle, and you'll be able to solve all questions on projectile without having to cram any formula. So what is projectile motion? It is a motion in two directions. Assuming you have a ball projected at an angle, let's try to draw it. Assuming you have a ball projected like this at a particular angle, let's call the angle theta. Now this ball leaves with an initial velocity, let's call it v0. You understand that if this ball travels from here to this point, in the y direction, the ball, there's a movement in the y direction from here to here, and there's also a movement in the x direction. So projectile motion is motion of two directions. You'll be considering both the y-axis and the x-axis. The initial velocity that this ball leaves with, there will be initial velocity on the x-axis, and there will also be initial velocity on the y-axis. Now, how do you find this initial velocity? If I should bring this thing out, you have something like this. This is the initial velocity. Now, how do we find the initial velocity on the x-axis and the one on the y-axis? You still remember, you must have had this must have had this from trigonometry. Now, the component of this initial velocity on the x-axis, this is the side facing the angle, so this is the opposite, and this is the adjacent. So adjacent, and here is the hypotenuse. So adjacent and hypotenuse is you're going to use cos. So if you want to find the initial velocity on the x-axis, you're going to use v0 cos theta. So this gives us the initial velocity on the x-axis. So let's call it v0 of x. And now the one on the y-axis, this is opposite hypotenuse. So you're going to be having v0 opposite hypotenuse, v0 sine theta. So let's call this v0 of y. So this means that when a ball is projected with an initial velocity, there is initial velocity on the x-axis and there's also initial velocity on the y-axis, and this is how to find them. You need to also know that on the x-axis, if we neglect air resistance, the velocity on the x-axis will be constant. And if velocity is constant, there will not be acceleration. So acceleration on the x-axis is equals to 0. Now on the y-axis, there is force of gravity acting against the ball. So acceleration on the y-axis is equals to negative 9.81 meter per second square. Now if you understand these things, the only other thing you need to know before you solve projectile equations is the three equations of motion. I hope you still remember. These equations. These are the only equations you need to solve questions on projectile. Every other equation comes from here. You just need to understand the one to use and how to use it. Now look at this. This is final velocity, this is initial velocity, this is acceleration, and this is time. If you're considering motion on the x-axis, this becomes final velocity on the x-axis. This becomes what? The velocity, the initial velocity on the x-axis, which is what? v0 of s, which is v0 cos theta. Remember how we got this? Now this becomes the acceleration on the x-axis, and we have defined that our acceleration on the x-axis is 0, so this will be equals to 0. This is the time taken, and once here is 0, this is cancelled. So it means that for the x-axis, your final velocity is equals to your initial velocity. So you just need to understand how to use these equations, whether you are considering the y-axis or the x-axis. Remember, in this equation, this is change in position, that is displacement. Now let's try to write this equation for both horizontal motion and vertical motion. Now in the horizontal motion, which is the x-axis, if you want to write this first equation, it just has to be the v on the x-axis is equals to the initial velocity on the x-axis. What is it? V naught of x plus, supposed to be plus at, but we know that ax on the x-axis is 0, so this becomes your vx is equals to v naught of x. Now for this change in position on the x-axis, so we call it x minus x naught. Change the position on the x-axis from, so this is equals to u is your v naught of x times t plus the rest. This is half ax t square, but you know that this is 0, so this tends to this. So you have that your x minus x naught, which is the change in position on the x-axis, is equals to v naught of x t. And for the last equation, which is a v square of x, will be equals to what? V naught of x squared. Remember, this a is still a of x, which is 0, so this is this. When you square, if you want to find your v from here, you will see go back to this place. So this tells you that the velocity on the x-axis is constant. Now for the vertical motion, you have that from the first equation, vy, that's the final velocity on the y-axis, is equals to v, remember this is your initial velocity on the y, so v naught of y is supposed to be plus at, but you know that ay we have defined it to be negative, so you're going to have something like this. Now for the change in position, which is your displacement, we use y minus y naught, which is the final position on the y-axis minus the initial position on the y-axis. So this will be equals to v naught of y t minus half ay t square. And the final velocity, if you want to look for the final velocity on the y-axis, is going to be v naught of y square minus 2a change in position on the y-axis, which is y minus y naught. Now you don't need to cram, you don't even need to cram all these formulas. You just need to understand them. So from each question, you will know the one to use. Once you understand the one, what you are looking for, you know the one to use. Now let's solve an example. Now you have a question: a projectile having a mass of 8 kg is fired with a moving velocity of 478, that's the initial velocity, at 45 degrees to the horizontal. Now you're asked to find the maximum height attained and the velocity Vy at the maximum height. Also find the time to reach the maximum height, T mass. First thing, you have to draw this projectile to be able to analyze it from first principle. So let's draw it. So this projectile was fired with initial velocity V naught to be 478 meters per second. This angle is 45. Do we have any roughing? Now we are asked to find what the maximum height, which is from here. Look at the maximum height the projectile attained. That is from here to here. So you can call it y mass, because this is in y direction now. So you call it the maximum height the projectile attained. And which other thing are we asked to find? We also asked to find the velocity at this maximum height and the time to reach this maximum height. So everything is just on this maximum height. So what is the first thing we do? Remember we said that this V naught, the initial velocity that this projectile is fired with, it has component on both the x-axis and on the y-axis. So let's try to find the components. Now, V naught of x, if you're considering this V naught from what we did earlier, it is going to be Remember, it is the velocity on this x-axis, so it is here and here is the hypotenuse, and remember this is your adjacent. So v naught of s is going to be v naught cos 45. All right, and v naught of y is going to be v naught sine 45. So this is equals to 478 cos 45 and 478 sine 45. This is going to give us approximately 338 meter per second. Same value here. It does not mean that your v naught on both axes will always be the same. Now the first question is the maximum height attained. How do you find it? What is maximum height? Maximum height is in the y direction. All right. So how do you find? You are considering the vertical motion now. So how do you find the maximum height? Let's go back to that 3 equations I told you. That's all you need to know, which is the equations of motion. Here we are looking at maximum height, which is change in position in the y direction. Which of these equations do you think we can use? Remember, this is also displacement, which is change in position. If you want to use this, can it work? If you want to use this, this means initial velocity, which we know on the y-axis. But do we know the time to the maximum height? We don't know, but we can get it. We can also use this. This is final velocity on the maximum height. This is initial velocity, and this is change in position on the maximum, which is your y minus your y naught. So let's try to use this. You can use any of these formulas to solve, but let's try to use this and see what happens. Now for the maximum height, if you are using the second, which is v square equals to u square plus 2ax. Now in the horizontal direction, this becomes v of y square equals to v naught of y square. Remember, in the horizontal direction, the acceleration on the y-axis, in the vertical direction, in the y-axis, in the vertical direction, the acceleration on the y-axis is negative. So you have negative 2ay. This change in position now becomes what? Y minus y naught. That is from the diagram, looking from here. This is what we are looking for. So this is our y minus y naught. All right. So now now you need to understand that this projectile, when it's projected, just like when this thing is going up, before it starts coming down, it goes to a point that the velocity becomes 0, and then it starts coming down. So at the maximum height, your velocity at the maximum height is 0. You just need to understand this. The velocity at the maximum height is 0. So if velocity on the maximum height is 0, this is so this is 0 now. So this becomes, okay, let me write it. We'll be having 0 squared is equals to, what is our v naught of y? We found it to be 338 squared minus 2. What is ay? 9.81. This is what you are looking for, the change in position from 0 to the maximum height. So this is what you are looking for. So from here, automatically, let's do so our change in position is equal to 33a squared over 2 times 9.81. So this is your maximum height, and this is equals to, you have a 5822.83 meters. So this is your maximum height. That is from here to here, from when y is 0 to this point. This is 5882.83. You can as well decide to use the second equation. You're going to get the same answer. So let's try it. So anyone that works for you, you don't need to cram it. You just need to understand it and you play around with the equations. If you want to use this second equation, this becomes our y minus y naught is equals to v naught of yt minus half ayt squared. All right. Now the problem is, how do we find the time taken to reach the maximum height? Because we need it in this equation. So how can we find the time? We can use the first equation of motion to find the time. Remember this one, v is equals to u plus at. All right. Remember, we have defined that at maximum height, velocity is 0. So we write this like this: v naught vy equals to v naught of y plus at. So using the first equation, v naught of y minus, remember ay is minus, so that's why you have minus here, at. So let's try to find the t to reach the maximum height. And we have defined that at maximum height, velocity is 0. So this is equals to, what is our v naught of y? We found it to be 338 to minus 9.81 t. From here, your t is equals to this. All right, when you point this, your t is equals to this. Now going back to this equation, this is what we are looking for: maximum height. And v naught of y is 338. Our t, time to reach the maximum height, we have found it to be this. So ay is negative of 9.81, which is this, and then the time, you square it. So you notice that the answers are the same. So you don't need to cram it. Anyone that works for you, just go ahead and use it. Now let's solve the next question, which is what? What is the next question? We have found what? Look here. Find the maximum height at 10, which has found to be 5822.83. And velocity Vy at the maximum height. What is Vy at the maximum height? Do you need to solve anything? Vy at maximum height is what? You should say it. You should know that it is 0, because that is the velocity the projectile attains before it starts coming down. So the v naught at maximum height is 0 meters per second. Now time, also find the time to reach the maximum height, which we have found it when we are using this second formula. Remember, this is the time to reach the maximum height. So if you use this formula to look for your maximum height, technically you are going to get your maximum height when you are solving the question. If you have watched to this part and you have gotten value, please subscribe to the channel so that you don't miss out on our videos. Remember, here we teach for first principle. Thank you. Like, share and comment. See you in the next video.